Welcome to our video. Our goal is to construct and test a few basic bridges to test the effectiveness of different designs and to illustrate the forces that cause these bridges to fail. A force acting on the center of a bridge applies torque, which is equal to the distance of the force from a support times its magnitude. This explains why longer, unsupported bridges are more feeble. The opposing torques cause tension on the bottom of the bridge and compression on the top. Once the compression and tension become too great for the bridge, it breaks. The first and most basic bridge is the beam bridge. This is a bridge that is simply a platform held up only by vertical supports between the bottom of the bridge and the ground. Adding additional vertical supports increases the structural integrity of the bridge by decreasing the torque that a force can apply on its surface. Next is the truss bridge, which is constructed with an assembly of triangles. This assembly is commonly placed above the bridge, but it can also be constructed underneath. It distributes the forces throughout itself, lessening the forces that act on the bridge's surface. The bridge is primarily held up by tension forces. The last bridge we will be testing is the arch bridge. The arch bridge is essentially a semicircle that diverts the weight of the bridge to its base and ultimately to the ground. The bridge is always under compression forces that are distributed along the curve of the arch. Now, let's print the bridges. We were able to configure the CAD model so that all three bridges could be printed at once. The entire print only took about 3.5 hours. Now that the bridges have been constructed, we will test the weights that each can hold. Since every bridge is exactly half an inch or 1.27 centimeters thick at its center, strength can be systematically tested by adding weights in even intervals at a point in the center of each bridge. The truss bridge was able to hold more weight than was available to us. Therefore, we decided to weaken it using other methods. After breaking the bridges, we recorded weight in pounds and in newtons that each bridge was able to sustain. We also determined the build material required for each bridge. Overall, the truss bridge had the best weight held to material ratio. Thanks for watching.